We've all been there, right? You get that pit in your stomach, it's the middle of the day, everything seems to be going just fine, and then bam, the alert hits. A 500 error in production. Suddenly, all eyes are on you. Well, today we're going to walk through a really clear, step-by-step workflow using this powerhouse trio, Sentry, Grafana, and Loki, to get you from that initial alert to the root cause and fast. Okay, so check out this timeline. This is basically our game plan. At 2 p.m., the alert fires. Just 2 minutes later, we're in Sentry getting our first clue. By 2:05, we're in Grafana figuring out just how bad this is. Then at 2:08, we use Loki to find that smoking gun. And by 2:15, we're already documenting the fix. You see how each tool just passes the baton to the next? It turns that stressful scramble into a focused, calm investigation. This is all about being systematic, not panicked. So, the scene is set. It's 2 o'clock in the afternoon. An alert fires. Slack is suddenly blowing up with notifications. And worse, users are reporting that the checkout process is just failing. A big, ugly 500 error. Okay, our incident has officially begun. Now, your first instinct, that old impulse, might be to SSH into a server and start tailing log files, right? But in a modern stack, that's not our first move. We don't go to the server. We go straight to the code. We want to start with the tool that actually caught the error in the act, the one that can give us the who and the what of this whole mystery. And that, of course, brings us to our lead investigator, Sentry. Sentry is a developer-first error tracking platform. Its entire reason for being is to capture exceptions in real time and serve up all this immediate, actionable context right where the code actually breaks. This is where we're going to find our first solid clue. The beautiful thing about Sentry is it gives us so much more than just a stack trace. It actually gives us a story. It leaves this trail of events called breadcrumbs that show us the user's exact journey and the application state right before everything went sideways. Think of it like a forensic timeline leading right up to the crime scene. And let's be super clear about what breadcrumbs are, because this is important. Unlike raw text logs that are just, a wall of text, breadcrumbs are structured data. They have types, categories, and severity levels. And that structure is what makes them so incredibly powerful. We can see not just that something happened, but precisely what happened, step by step. So for our specific checkout failure, the Sentry issue tells us two absolutely critical things. First off, the stock trace points directly to our payment service. Okay, good to know. And second, the breadcrumbs show that the very last thing that happened before the crash was a post request to the /API/checkout endpoint. See? The investigation is already getting much, much narrower. So Sentry gave us the what, an error in the payment service, and the where. It's happening during that checkout API call. But here's the million-dollar question. Is this affecting one unlucky user, or is it hitting everyone? To figure that out, to really understand the scale of the problem, we need to zoom out from the code level to the system level. And that's our cue to head over to Grafana, our single pane of glass for all of our system metrics. This is basically mission control. It's where we go to see the health of our entire infrastructure and to really understand the blast radius of this incident. And boom, on our checkout service dashboard, the impact is, well, it's undeniable. There's this huge, jagged spike in the 500 error rate, and look where it starts, right around 1400. So this isn't some isolated bug affecting one person. This is a widespread, service-impacting event. Now we know this is a big deal. Okay, so the very first thing we do here is narrow our focus. We use Grafana's time picker to set the range from exactly 1400 to 1405. This instantly filters out all the noise and correlates every single metric, log, and trace within this exact window. It's how we isolate the problem from all the other system chatter. And this is where the magic really happens. Instead of that nightmare of flipping between browser tabs, trying to manually match timestamps between different tools, Grafana's split view lets us see our metrics and our logs side by side. We can literally click on that error spike in the graph, and Grafana instantly shows us the logs from that exact moment. This isn't just a convenience, it's a massive time saver when every second counts. All right, so we've confirmed the blast radius. We know this is a big problem affecting the whole checkout service. We've seen the spike. Now it's time to pivot. We need to go from these high-level metrics down to the ground truth, the specific log messages that hold the answer to the question, why is this happening? And this brings us to the final tool for our diagnosis, Loki, Grafana's log aggregation system. It's built specifically to query just massive volumes of logs, using a really simple label-based system. It lets us slice and dice our data to find that one crucial message we're looking for. So how do you actually talk to Loki? Well, you use a language called LogQL. The really cool thing about it is that it lets you create a schema at query. Now, what that means in plain English is you don't have to get everything parsed perfectly on the way in. You can filter, parse, and structure your log data on the fly as you're investigating. It's all about power and flexibility, right when you need it most. You know, a LogQL query really just has two basic parts. First, you use labels in what's called a stream selector, something like service equals checkout, to grab all the logs from the right service. Then you use these pipeline operators to filter those log lines down, maybe searching for keywords like error or parsing them if they're structured as JSON. So here's our exact query. We select logs from the checkout service in our production namespace. Then we filter for lines that contain the word error. Next, we tell Loki to parse that log line as JSON. And finally, we only show the logs where the status code field is 500 or greater. This is like a surgical strike to find exactly what we need. And there it is. Seriously, that's the aha moment right there. A single log line that tells us everything we need to know. The root cause isn't some complex bug in our code, it's a simple operational issue. Our payment provider's API key is invalid, or maybe it just expired. We've found the smoking gun. Now the fix here is easy, right? We just roll out a new valid API key and the service recovers almost instantly. The fire's out. But we're not done. The work is not over. The single most important step for building a more resilient system is documenting what happened and why, so we can make sure it never, ever happens again. And this brings us to the idea of the blameless post-mortem. And that word, blameless, is so important. The goal here is absolutely not to point fingers or blame anyone. It's to understand the systemic reasons that allowed this failure to happen in the first place, and then turn a really stressful incident into a valuable learning opportunity for the entire team. This is how we actually get better. So this all boils down to a really simple, repeatable process for closing that loop. First, you finalize the timeline of events. Then, you clearly document the root cause. Next, you create concrete action items, like, say, adding automated monitoring for API key expiration, and you assign them to people. And finally, you share what you learned with everybody. All right, let's just boil this whole workflow down into a super simple checklist for you. Start with the code-level error context you get from Sentry. Then assess the impact. The blast radius with metrics in Grafana. Pinpoint the root cause with really targeted log queries in Loki, and always, always, always document what you learned to build a stronger system for tomorrow. So I'll leave you with this final thought. We showed you how Grafana's split view can help correlate metrics and logs pretty easily. Now I want you to think about your own systems. How can you tighten that integration even further? How can you make the leap from seeing a problem to understanding its cause a seamless, maybe even a one-click process?